Today we'll learn how to solve a stoichiometry problem when the problem asks you to convert from grams of one substance to grams of another. In this problem, we have how many grams of water are produced from 5 grams of hydrogen gas. The 5 grams of hydrogen gas is our given, and the unknown that we need to find out in this problem is how many grams of water are produced. Whenever we're doing a problem like this, the first step is to balance the chemical reaction that you see. So I'm going to write down the steps as I do them. Step 1 is to balance the reaction. It's important to balance the reaction because that gives us the molar ratios. So this particular problem, when it is completely balanced, we have 2 moles, remember this means moles, of hydrogen gas, 1 mole of oxygen gas, and 2 moles of water produced. Step 2 to solving a problem like this is to find the molar mass of the reactant and product that you need in the problem. So now we're going to calculate the molar mass of the reactant and product. Reactant and product. We've calculated molar mass before. This is where you take the molecular formula, break it down into its atoms, find the mass from the periodic table, and multiply by how many atoms there are. So the molar mass of hydrogen gas is 2.02 grams per mole. The molar mass of water is 18.02 grams per mole. The third step to solving a problem like this is we have to convert our grams of reactant into moles. That is the universal language of chemistry. We can't go straight from grams of one substance to grams of another. So our third step will be convert reactant grams to moles. And the way that we do that is by using the molar mass. By using the molar mass. If we think of this as going from the language of grams to moles, molar mass is your translator. So let's take our reactant. We had 5 grams of reactant, 5 grams of reactant, H2 in this case. We're going to multiply that by our conversion factor, where in this case the conversion factor will be our molar mass. Grams of H2 goes on the bottom, so my units match, and my new unit, moles of hydrogen, goes on top. In the molar mass, since the number is next to grams, that is your hint that the 2.02 goes in the denominator. 1 mole on top. So grab your calculator and you need to plug in 5 divided by 2.2. And we get about 2.48. I'm going to stick with my colors here, moles of hydrogen gas. So now we've converted our reactant grams to moles using the molar mass. The next step is we're going to take this answer and we're going to convert from moles of our reactant to moles of the product. Step 4. Convert moles of reactant to moles of product. We're going to do this by using the molar ratio this time. So we'll start with our given, which is the 2.48 moles of hydrogen that we just calculated. We'll multiply by a conversion factor, just like every time, where that conversion factor now is the molar ratio. We know that moles of hydrogen should go in the denominator so that the units match. And moles of my product need to go in the numerator. We find the molar ratio by looking at the moles in the balanced chemical equation. So I have 2 moles of hydrogen gas, 2 moles of water, 2. That makes this problem pretty simple because anything divided by itself is just 1. So this is 2.48 times 1. So we get 2.48 again. But the moles of hydrogen and moles of hydrogen have canceled, so we're left with moles of water. Now we've essentially solved the problem. We've figured out how much water is produced, but in the wrong unit. So the very last step is convert product moles to grams using molar mass again. But this time we want to make sure that we're using the molar mass of the water. So we'll take our answer, 2.48 moles of water, multiply by a conversion factor, just like every other problem. And here we're going to put the molar mass of water. Moles of water in the denominator, so my units match. Grams of water in the numerator. The molar mass of water that I found earlier is 18.02. 18.02 grams per 1 mole. So the last step is use your calculator to find 2.48 times 18.02. And I found 44 I'm going to round this, 69 grams of water can be produced from 5 grams of hydrogen. That is my final answer to this 5-step problem.